this is structured one. Okay, so the raw data must be stored in a structured way. So we use that SQL Server, MySQL, Oracle. So these are all the tools which you can use to create the data structure to save the data from the data lake. From the wearable device, the data comes to the data lake, which is in the raw format, and that will be acquired by this tools, SQL Server or MQ, MySQL, Oracle kind of tools, and it can be saved in a more structured manner actually. So it will do the filtering and pre-processing of the data, okay, so that it can be further analyzed. Okay, so some sort of filtering. Filtering means removing unwanted, redundant data in that, and converting it from the basic raw format to a useful format will be done by this data storage tools. Okay, this is a higher layer. Okay, first we have the data lake, then you have the database or data storage, and then you have the next higher layer. So this also does filtering and pre-processing data from wearable devices for further analysis, means for further access by the application. Okay, so this also process your data, raw data, and save it in a structured manner, so that whatever information you need will be able to easily access from the data structure. Okay, so only if it is saved in a structured manner, whatever feature we need about a particular individual will be able to acquire through an application software. So this is necessary to create a data structure and save the information such that they can be conveniently accessed by the application softwares. Okay, maybe from a mobile application, we'll try to access some information about an individual from this cloud server. So these tools will help to provide the customized data to that particular app. Okay. So this more or less all related to that pre-processing and filtering of the data tools. Okay. Then next layer is data analytics. Okay. So what is the purpose of data analytics? So it will analyze the data of a particular person over a period of time repeatedly, and it takes statistics about that patient actually. Okay. So it finds trends in stored patient data, whether the health condition is improving for a patient. So the doctor may suggest us some medicine for 1 week, and we take that medicine, whether the medicine is making any improvement in the patient health. So we not to go to the doctor every day. So our data will be going to the cloud server, and the doctors will be able to access it, and they'll be able to monitor. So if there is any discrepancy or any abnormal condition, that will be indicated to the doctor, and he could take corrective action. He could recommend stopping that medicine, or he could suggest continue that medicine for another week, like that. Okay, so this is IoT data analytics. For example, I'm a normal person now. If my data is analyzed for over a period of 6 months or 1 year, and there could be some system that will indicate so I'm getting weaker, or something has to be taken care. So I'll get a early warning. That's the important thing. So the data analysis system can provide me a early warning. Okay, so your health data is going this way, so there could be a probability of having this health problem for you. It's recommended to have a check. So that kind of information I will be able to get when you perform this IoT data. The data is saved in a structured manner. Then we analyze that data. Okay, so to analyze the data, we will use these tools actually. All these are available when you choose a particular cloud server. They provide the tools for each protocol stack actually. For analytics, what tool you can use? If you are using a AWS server, then AWS IoT analytics tool can be used to analyze the data, okay, and then give customized information or suggestions to the particular person. Okay. So patient rehabilitation effectiveness. So that's an example I told. Doctor is recommending a medicine or some treatment. I'm undergoing that. Whether it is improving the health condition of that patient, okay, that will be easily monitored by the doctors and hospitals. So if they see any trend in the improvement side, then they could suggest to take the treatment for some more time, or they could change that prescription or medicine, whatever it is. Okay, 1 minute. Sorry. So why I'm discussing all this is that if you are developing a wearable application, you can go for interdisciplinary projects. So you can combine students from ECE, CSE. So combined you can do, because if you start with a wearable project with EC faculty and EC students, so we'll focus only on the device, so how to connect the sensors, how to collect the data. But if you include some CSE people in your work, then you'll be able to provide a full-fledged application. Okay, so they can work on how to get the, you are giving the data to them from your device, the data goes to the server, then they can work on how to create the data structure, how to do the data analytics, and how to create an app. So from that app, how you can acquire the data. So the full-fledged system can be implemented if EC and CC can work together. Actually, okay. So data analysis is more important. Okay, this is what gives information to the application softwares. So it is also part of that. Okay. So these are the layers you have in a cloud-based healthcare system. So we need a cloud server, then we need to ensure real-time data streaming to the cloud, and then we should have storage, data lakes, and then databases. You have to create a data structure and effectively save your data in the right format. And you can do filtering and pre-processing at this stage. Filtering means removing redundant data. Okay, pre-processing refers to converting data to different data formats. Okay? Right. And then analyzing the data. So we need some tools to analyze the data saved in the cloud server. Okay, data analytics. Okay. These two are different. Big data, data analytics are completely different. Big data is about how to save the data. That's one thing. And analytics is about how to take data from storage device, cloud, and how to analyze that and get statistics about from the data. Okay, that's two different fields actually. So backend, this is about the tools, the languages which you can use to implement different things. So backend. Okay, so in the cloud server, I have all the information. Now I need to get data from the cloud server. I'm developing an application which will get data from the electronic health system and provide information to the doctor, the patient, and some administrative people, maybe the government organization. So if I develop the application, I should customize the application for different groups of people. So for patient, I should give application. So he should be able to give his details and get his health parameter. Okay, a doctor should be able to see the health parameters of all the people. Okay, the government, the entire statistics, they will be able to see the statistics. For example, in the hospital, how many people have come for fever treatment or COVID treatment. So that kind of cardiac problem, diabetic problem. So they'll be interested in the statistics. So far, the government agency, I may be doing a data analytics to provide the statistics from the hospital records. So this comes under backend. It's application software. I can develop a mobile application or a web-based application using which I can go to the website and access the information. So this is up to the group for which we are developing, admin people, individual user, or a government agency. So this is separate from the cloud server. Okay, data is saved in the cloud server, and this is a separate thing. It is developed in the end device, and this will access data from the cloud server and present the data to the end users. Actually, okay. This is also part of that. You have saved data in the cloud, but you need to access the information from your mobile or from your laptop. So we need another a app. So this could be simply called an app actually. So I should have a web-based app in my desktop or in my app so that I'll be able to get information from the cloud. Okay, this is also part of that. But it's called backend because it is a separate unit that's used by the end users. This is for mobile app development. This is for web-based application development for the individual users or the admin group people. And this is the tool which you can Android popularly now use only the Android tool for developing applications. You can develop an Android app or an iOS app. So from the mobile phone, the user or doctor will be able to access the data. Okay, right. So this completes the full protocol stack of a cloud-based wearable healthcare system. Okay. So front end is what you see in a web page actually. So here we can have HTML, JS. This will be useful to provide the web page for the user side or the admin people. Okay, and this refers to the languages we use to develop the app. Okay, so the front end is about the layout of the web page for the app. When you open the app, how it looks like, what are the GUI features you have. So that comes under front end. And here you can have JS, HTML. This you can use to create the front end of the app. Okay. So it is not an individual work. As an individual, we cannot develop a full-fledged wearable healthcare system. So it could be done as a team actually. A team of EC and CS people can combine together and develop a full-fledged product. Okay, that's that. Okay, so now we'll come to the connectivity aspects actually. As you know, a wearable device is also an IoT application. So it's collecting data, connecting to the internet, and putting the data into the cloud server. So it is an IoT application. So it is estimated that already they have estimated, and it is proven now almost 50 billion devices are connected to the. They estimated long back, a decade back, but now it is true actually. Now almost 50 billion devices are connected to the internet. We just think that if every individual in the universe is wearing a smartwatch, then you can easily imagine how many devices will get connected to the internet. Okay, so you have a huge connectivity issue. Okay, so the density of the devices are increasing day by day. Okay, if you take a mobile phone, that could be hardly 1,000 or 2,000 users in a base station coverage area. But now, when you take this IoT devices, it could be more than that actually. So the number of devices per unit area is increasing year by year actually. So how we can manage the connectivity issues? And that's why they have, because all this will be communicating with the internet. So the earlier we have used IP version 4, now it has been upgraded to IP version 6. There is a saying actually with IP version 6. That's how the internet protocol has been already upgraded, okay, to support IP version 6. With IP version 6, we have a large number of bytes for the IP address, and there is a saying that every grain of the sand can be identified by an individual IP address in IP version 6. That is true actually. It means we have still more space for more devices to be assigned to individual IP address. Okay. With IP version 4, it's limited. We can't connect this much devices with IP version 4. So the TCP/IP protocol has been upgraded with IP version 6. Okay. So with that, even you could accommodate 50 billion more devices with IP version 6. Actually. Okay, that's one thing they have already upgraded. And if you look at this, the Internet of Things, okay, wearable is a part of that. Okay, because we do the same thing. We collect data and push it to the cloud server. It is part of the IoT application. And you can see the similarity of the IoT 7-layer architecture and the wearable device, cloud-based wearable systems, more or less the same. Okay, so usually we'll have the 7 abstraction layers in a IoT application. Okay, it's true for a wearable device system also. Okay, so this is what we have discussed actually. So the physical layer is the device, okay, your sensors, actuators, and the microcontroller you have in the wearable device, okay, maybe a smartwatch. And then connectivity, it is the communication standard you have, maybe a 2G, 3G cellular modem, or a Bluetooth modem, or Wi-Fi modem, or LoRa modem, whatever you add to your physical device and controller, that provides the connectivity actually. And edge computing, edge computing is a new technology. It's becoming more popularity. Okay, I'll come to that next. So we have seen the data accumulation, that's data lake. Okay, data abstraction is data accumulation, nothing but data lake actually. We just put the raw data into that. And data abstraction is filtering and pre-processing. And then application, it's analytics. We have seen we have to do data analytics and report to the application. So that comes on that. So here, an additional thing we see nowadays, edge computing. Okay, earlier in a IoT system or a wearable system, the processing of the data is done only at the cloud server. Okay, you could remember Google Voice Assistant and Google Computer Vision. So you speak to Google in a phone, you can do a voice search, right? Just you speak what you want, and your voice sample is recognized. So that voice sample is recorded, it is processed and sent to the Google Cloud actually. So actually recognition is done at the Google Cloud platform, not in your local device. It seems like we see immediately the result in our mobile phone. If my children used to, I haven't done that. So they are doing voice search with Google actually. So they speak to that, the speech sample goes to the cloud, and voice recognition is done at the Google Cloud server, and then the result, what is the spoken word, that is recognized, and then the result is printed. So the processing is done at the cloud actually. We get in the end device, we get only the result. That was a trend. Okay, because in the edge device means the device which you wear, that's called an edge device. Okay, in the edge device, we don't have enough computing capability, so to process that. If you want to do that voice recognition in the edge device itself, you can't do that. We'll be using a 8-bit or 16-bit microcontroller there, which is not capable of doing that. But now, even the edge devices are coming with, even the wearable smartwatch you take, it comes with ARM Cortex A series core actually. So almost all the processors are coming with 64-bit core. 64-bit core is coming with. So that enables some level of processing in the edge device itself. Okay, the advantage is the latency will be reduced. So if you are sending data to the cloud, if processing is done at the cloud, then I am getting a result, and then I make a decision. So more latency will be involved in that. Of course, it is fraction of second, but in some systems, fraction of second does matter. Okay, so from 1000 millisecond, if it is reduced to 100 millisecond, hundreds of millisecond does matters in some applications. Okay, so edge computing is a reality now actually. Many single board computers are coming with huge computing power. I'll show at the end, there are some GPUs coming with edge computing features. You can buy a single board computer and it can do that processing in the edge device itself. So you can reduce the overhead of the cloud server. Okay, if all processing should be done at the cloud server, you see what are things you have. The cloud is overloaded, that's one thing. And then communication overhead is also higher. When all the devices are sending its data to the cloud, then we have connectivity issue. More bandwidth is required. Okay, that's a serious problem. When all the devices, all the data is put to the cloud. Okay, you take care. Why do I bother? Then connectivity problem will be there. You'll have bandwidth scarcity. Okay, we need to have more bandwidth. That's a problem in communication actually. So if some part of the job can be done at the edge device itself, so you can save the bandwidth. Okay, you need to have more frequent communication. Okay, so you can save the bandwidth, you can reduce the overhead of the servers actually. Okay, and also it could be secured also. If some processing is done locally, it could be more secured also. It may not be applicable for all applications, but some tasks can be done at the edge computing level. Okay, for example, I am having a drone. Okay, or a smart agricultural system, for example. Okay, so the sensor data will be collected and it's going to the cloud. But if some decisions can be made at the gateway itself. Okay, so mostly at the edge device, if possible, if you want, you can make it. Okay, you can put a powerful processor in the edge device, your wearable device, and it can make decisions. That's one thing. Then the gateway, in the gateway, you can provide edge computing. Okay, at different layers, you can have that. So gateway also do some pre-processing and then filtering. It can do, right? The data goes to the gateway first. So you can have a powerful processor. Gateway is not portable, it is fixed somewhere. Okay, only the wearable devices are portable, but the gateways will be mostly fixed. So you can add a computing unit in the gateway device. So that's called edge computing at the gateway. Okay? The gateway can do pre-processing of data, filtering of redundant information, and then it will send what is essential to the cloud actually. So that will also lead to the saving of the bandwidth. Okay. Earlier, it was not possible because the price of that computing processor was costly. The board was very costly. But now we are able to get 64-bit ARM Cortex A series core at an affordable price. So even the edge devices can also do some computing. Okay, computing means pre-processing, even analysis. They can do data converting from one data format to another format can be done at the lowest layer in the physical device, okay, as well as the gateway level. At these two levels itself, you'll be able to do some level of computing actually. Okay, so that's the trend, and more or less now, as the complexity of the wearable device is increasing, that is, the device we use in the wearable band or watch is becoming more and more powerful. So most part of the job can be done at the edge itself. Okay, that is the trend in cloud computing today or IoT today, edge computing. Okay, so they want to do most of the task at the edge system itself. At the edge means that end node. That's your wearable device. So they want to do everything at the end node itself, so that the connectivity issue can be solved and the bandwidth requirement can also be reduced actually. Okay, so you can search and find the best edge devices. Okay, so that you can reduce the reliability on the cloud platforms. Okay, I hope it's clear. Only if you could do all this, then it is a complete product. Okay, so it involves the involvement of the computer science people and electronics people. Okay, that's what I want to stress. So earlier the trend is gone. If I'm starting with the IoT project, I'll put some sensor, some Arduino device or ESP, collect some data, show the temperature. That's all. That's what. But it is just one or two devices. That's a very small data. But really, if I want to get job in IoT field, I must have exposure to the big data analytics. Okay, because when millions of data is coming from millions of devices are pushing the data to the cloud, how to work on such large size data, that knowledge is very much essential. That's a real IoT engineer's requirement actually. So we should all have some exposure to that cloud tools as well. Okay. Okay, so how a wearable device normally communicates to the cloud? Through the gateway, of course. Okay, so the protocols could be TCP or UDP. You know, this is what we use in Wi-Fi actually. So if I use this TCP or UDP protocol stack in the edge device, there will be more overheads. You know, all could have studied computer networks. In TCP IP protocol, the overheads are enormous. It could be a small message, but the number of things we add to that data is more actually. The frame structure is more complex, and we add more header bits to that in TCP protocol, TCP IP protocol actually. So if I use this protocol in my wearable device, then it requires more bandwidth. And then I need to use a higher frequency spectrum actually. So mostly what they do not use TCP IP in the wearable device. So instead, they can use some lightweight protocol like MQTT. So the CEO, some lightweight protocol can be used so that it reduces the bandwidth requirement and the spectrum requirement also, of course. Okay, and then through gateway you can have connectivity to the cloud in TCP protocol. So the gateway is a fixed device, and that can be connected to the internet, and it will communicate to the cloud through the TCP IP protocol. But from your wearable device to the gateway, you can use some lightweight communication protocols. So MQTT, these are all data protocols, data formats actually. So when compared to the TCP/IP data format, MQTT protocol data format will be very small. The packet size is very, very small actually. That is more than enough. So it reduces the bandwidth. More the bits you have in a message, then bandwidth requirement will be more. So if you use some lightweight data communication standard is different. It's about the frequency range and modulation, and data format is different. Okay. So what are the overheads you add to a data? That's a data format. Okay. So that's usually a feasible solution, a really feasible solution. Instead of making your device directly connecting to the Wi-Fi with TCP/IP, you can use some lightweight protocol like Bluetooth LE. NFC is not used. Narrowband IoT, a low power WAN, Zigbee also outdated now. So BLE is popular, and BLE is popular. Narrowband IoT, that are popular lightweight protocols actually. Okay. And they can communicate to gateway. Through gateway to server side, it will be TCP/IP. Right up. Well, 11:30. Okay. So now we'll see what are the various communication protocols, that's communication standards that are suitable for this wearable device or IoT connectivity. Okay. So Wi-Fi we can use. I'm not denying it, but if you use Wi-Fi connectivity from your edge device to the gateway, or from the edge device to the cellular, most of the smartwatch we use now, it will use the cellular protocol from your device. It directly communicates with the cellular network actually. Okay? The same way how we access internet data through mobile cellular network. So that same protocol is used for pushing your data into that. So you need more data usage. Okay, that's one thing, and you have to pay subscription. Okay, every month you have to pay subscription for this. That's one thing. So if it is an individual, if it is a home application, I can use Wi-Fi also. No need to use a cellular network. I can use a Wi-Fi protocol to communicate data from a wearable device to the cloud server. But that's possible, but not advisable. Okay. The other thing we can use is Bluetooth low energy, narrowband IoT, and LoRa band also. Okay. LoRa band you can prefer using if you are in a campus. If you are restricted to a particular campus, for example, you are staying in a hospital environment. Okay, the people, the hospital management want to track people who are in the hospital as long as they are in the hospital. The hospital may be spanning over 5 to 10 kilometers span area. Then in that area, I can use LoRa. So I can design my own device. Okay. So if you buy a smartwatch from the market, whatever protocol it uses, you have to adapt to it. Okay. But you can, if you for this kind of application, you can make your own device. Okay. That's what it micro integrated circuits people have discussed actually. So you can put whatever required in a chip actually. You can make your own device and add that LoRa band to it. Now 11:41. Ground floor. Yes. Okay. Okay. So narrowband IoT, LoRa and all we can use if it is meant for a specific region actually. The campus monitoring, if you want to, you can use LoRa. Right. Any commercial product, if you buy, mostly it will be with the cellular network technology or the Wi-Fi. Okay. Some device may support Bluetooth also. From your smart device through BLE, it will push the data to the mobile phone. Then mobile phone to cellular network, it goes. Okay. So now we'll show you some features of each of the connectivity protocols. Okay. These are meant for IoT, and specific application is also mentioned. Okay. So you see here in this Wi-Fi Halo, this is a new standard, a substandard in that Wi-Fi. 802.11 is a Wi-Fi IEEE standard. So in that they have introduced a substandard that AH, and the key difference, it uses sub 1 GHz, lower than 1 GHz frequency. Normally the Wi-Fi frequency range would be 2.4 GHz or 5 GHz or even 7.5 GHz. That's a Wi-Fi band normally for routers and all. But for IoT application, they have identified a sub 1 GHz frequency band, the 600 to 800 megahertz band. Okay, it will use that because for IoT devices we need less bandwidth. Okay, for example, instead of TCP/IP data format, if I use MQTT or some lightweight data format, it won't require that much bandwidth like the TCP/IP data format. So I can conveniently transmit with this sub 1 GHz carrier frequency, and it is meant for the short range. 1 kilometer is fairly high actually. Okay, and throughput you can get is around 40 megabits per second. So latency is around 100 milliseconds. That's a delay in communication. And what are topologies it will support? Mesh topology. So you can have your own network. Okay, these are all for industrial application, hospital applications. So they want to have their own network. Okay, so for individuals, that smartphone with cellular technology is fine. Okay, but for an organization, they will not go for that. They will have their own customized network. Okay, so they can order with the people who make a wearable device, and they will get the device with whatever protocol they recommend. Okay, right. So power consumption, normally short range connectivity solutions will consume very less power. So you'll have a long battery life. So Bluetooth low energy, you see it uses 2.4 GHz, range 100 meters. This BLE can support up to 100 meters. Data rate maximum 2 megabits per second, and latency is very less. It's a short range communication, so obviously the latency will be very less, 6 milliseconds, and it's meant for point to point. In Bluetooth, you can use to connect one device to another device. Normally, Bluetooth technology is not recommended for a network of devices. Of course, you may argue we have studied about PicoNet and ScatterNet, but it's a network of small number of devices. So PicoNet can only have 7 or 8 devices, and ScatterNet involve interconnection of several PicoNet. But that won't be convenient for a larger size of network. If the number of people in the hospital environment is more than 500 or at least 300, then Bluetooth will not be a good choice actually. So it is you can have a Bluetooth internet connectivity, that is interconnection only for a small number of devices. So mostly it is for point to point, from one device to communicate to other device, from your wearable device to the mobile phone. That's all, one to one. Okay, for that it is fine. So wearable device to the mobile phone, it happens with Bluetooth technology. Even in some of the wearable devices, wristband, or if you wear, it will communicate with the mobile phone through the BLE only. Okay, it is meant for that. Then Z-Wave, this is actually for reading data from the sensors actually. It's also a lightweight protocol that operates in the sub 1 GHz frequency range. Actually, before that Wi-Fi Halo, we had Z-Wave. Now, Wi-Fi in IEEE itself, they have created a sub-band Wi-Fi Halo. Okay, right. Zigbee, it was popular 10 years back, but not now. Okay, 10 years back, the best connectivity protocol for wireless sensor network. We studied on the topic wireless sensor network is Zigbee, but now we have other Zigbee. Problem is the protocol stack is more complicated. It's almost similar to the TCP/IP protocol. The protocol is more complicated, requires more bandwidth, and it is not adapted nowadays. Actually, it will support mesh technology. A decade back, Zigbee was popular, but now it is almost obsolete. You see, there's no wearable device coming with Zigbee technology nowadays, because that cost is also very high. The Zigbee transceiver cost, because of the complexity in the protocol, the standard, so the device cost is also very high. Earlier we used, in the beginning when wireless sensor networks were introduced, we almost followed Zigbee protocol. Okay. Then NFC, it's not good for a wearable device. It's for reading data. That's all. Okay, right. If you want to read data from a smart card kind of thing, you can use NFC. You can use it for your nowadays. We go to a hospital, take some scan or something. The data can be embedded in a card, actually, a smart card kind of thing. Then in that NFC could be used when you want to read data from the smart card with a reader. Then NFC technology would be helpful. GSM, this is long range connectivity. Okay, the initial problem we faced with the IoT connectivity or cloud connectivity is the range actually. So earlier, long-range vehicle tracking or seamless vehicle tracking, seamless tracking of people was not possible actually, because earlier protocols supported only Wi-Fi. You can have a microcontroller, a Wi-Fi modem or a Bluetooth modem, then you should connect to the internet only through that. Okay, so connectivity through the cellular network was not available a decade back. But now all the IoT devices are supporting this cellular network actually. So for long range connectivity, because now we have 3G under 4G.